All right, this is the Home Energy Auditor's Worksheet walkthrough, and we're going to start with question 1. Calculate the total heat transfer for 48 hours through a brick garage 3 inches thick with an R value of 0.4 per inch that measures 15 feet by 20 feet with a heating of 65 degrees to 20 degrees Fahrenheit outside. So we're going to work with that equation, and right away I can read it and know that I'm going to use the equation of QC over little t, which is time. So I have thermal energy over time, and that's going to be set up in the rest of the equation, which is 1 over its R value. So 1 over R, and that is times its area times its change in temperature. Now I just have to set up each part to my equation. All right, so if I'm setting up my equation, in the R value slot, I'm going to do 3 inches times 0.4 feet hours degrees Fahrenheit over BTUs, times that by my area of 15 feet times 20 feet. So I'm going to do that piece to the problem. And then my change in temperature of 65 minus 20 degrees Fahrenheit. So I'm going to do each one of these pieces and write out all these pieces for us and then times each section. All right, so now I've set up all my pieces, and I've got 1 divided by 1.2, and that's my R of feet squared, hours, degrees Fahrenheit, BTUs, times that by my 300 feet squared and my degrees Fahrenheit. So Fahrenheit and Fahrenheit cross out, and feet cross out. And so right now my answer when I times all these up are going to be in hours of BTUs, which will be equal to my QC over little t. And so let's times all those up, and the answer I get is 11.25, so 11,250, and that's going to be in the units of hours, BTUs, and on the other side of my equation of QC and little t. And now I have a set of times. So right now this is every hour. I'm losing this many BTUs through my energy. But I want to know for 48 hours. So I have 48 on this side in hours, and I have to move it to this side of my equation. So I'm going to do 11,250 BTUs per hour times that by 48 hours. And when I do that piece, I get my nice big number, and my hours crosses out, and my answer 540,000, and that is BTUs. So that is my answer to question 1. All right, for the next part we're going to work on question 3, which says you are looking to buy a 2,000 square foot home. The R value of the insulated walls are R10, the flooring is R10, and the ceiling is R10. The 2 locations for the favored home is in a 3,000 degree day regime or in a 3,500 degree day regime, and what is the difference between energy lost? And so for this question I have to use my degree day equation, which is the sum of all my R's times the sums of all my areas times 24 hours in a day times the degree day, which is in days per year per degree Fahrenheit. So I'm going to set up the equation, and the thing we want to remember is that the area has to count for the R values of every area that includes an outside surface. So I have to account for every external wall in the house, which if there's none given, we assume 4, and the flooring and the ceiling. So the R10s of every surface that would touch the outside. So in this case, I would have 6 surfaces that would touch the outside, giving it an R value of 60. So it's 1 over 60, And our values, once again, are in a set of feet squared, hours per day, degrees Fahrenheit over BTUs. So that's my R. And the area of my home in this set is 2,000 square feet. So my feet squared can go away. And the next part is going to be the 24 hours in a day. And then the final part will be in 2 different degree days a year. So before I do my degree days a year, I'm going to actually just set up this piece of the equation and give myself the answer, and then I can times by my 2 different degree days. So let's set that up, and just keep in mind that the hours and the hours are out, so that right now what I'm going to be left with in units is Fahrenheit BTUs per day. All right, so what I'm left with is 800 as a nice clean number for this piece of the equation, and now I'm going to add in the degree day part. So I have 800, and that's degrees Fahrenheit BTUs of a day, and now we want the year, and for location 1, I am in a 3,000 DD, so that's degrees Fahrenheit, day, year for my setup. And that allows me to cross out days and Fahrenheit, and I'm going to get BTUs per year. And when I put that in the calculator, I get 2,400,000. So nice big 2,400,000. And that is in BTUs per year. Now the next part, I want to set it up for a different location. So it's still 800 degrees Fahrenheit BTUs per day. I'm going to times that by my 3,500 degree day location, so that's Fahrenheit, days, year. So days and days are out, degrees Fahrenheit and degrees Fahrenheit are out. And when I set this up for my final part, my answer to this is 2800,000. And that is in BTUs per year. For the final part of the question, I'm going to subtract my 2,800,000 BTUs per year minus my 2,400,000 BTUs per year, and I will get my answer in how much energy will be lost in the difference of changing just that climate and moving down a little bit, and I will get 400,000 BTUs per year difference between the 2 home locations.